Welcome everyone. We'll get started right at 1 o'clock. So we'll give it about another minute to let people join.
Oh gosh.
All right, it is 1 o'clock. We'll get started with another session of Virtual Conservation Live. If this is your first session, welcome. If you're a returning guest, welcome back. Today we have Megan Gunn from Purdue University joining us. But before we get to that, we'll go over a couple of ground rules. Remember that the Q&A box within the Zoom is for either answering Megan's questions or for asking Megan some new questions that you would like her to answer on screen. Please don't use that for chatting with each other or making funny remarks, because we'll just get rid of those immediately. Second, if you're tuning in on Facebook, welcome. This program was created for Tippecanoe County fourth graders in substitute for what's called Conservation Field Day. That's an event that we at the Tippecanoe County Partnership for Water Quality host every year. My name is Ben, and most of our fourth grade attendees know Monica or Miss Christopher.
Hello, everybody.
So before we get started, we want to remind everyone that we're doing this Monday through Thursday this week. We have another presentation coming up tomorrow at 11 a.m. We'll be learning about bats, so that one will be very interesting. But without any further ado, Megan, please take it away.
Hello, everybody. So my name is Megan. I work for the Department of Forestry and Natural Resources at Purdue University. I am a student recruiter for the department, so I get to do a lot of outreach, which includes this video today, and a lot of getting kids excited about nature by doing hands-on activities, which we aren't able to do today, but hopefully sometime in the future we can do some more hands-on activities. I also manage one of the fisheries labs. It's an aquatic ecology research lab. And Ben, you said I can ask questions and they can answer it in the chat box?
Yes.
Okay. So does anyone want to take a guess as to what aquatic ecology might mean, or what I do in that lab? I'll give it a couple seconds. Yeah, water something, that's for sure. Working with fish and water. That's kind of spot on, Nadia.
Water something.
We test the water, yep.
Working with fish and water.
Megan's got it, Monica. She's reading the chat box.
Oh, she's got him? I didn't know that.
Oh yeah. So you guys are spot on. So what we do is we look at the fish and the animals that are living in the water and other animals that are living in the water. And we see how they're interacting with the environment around them and how those relationships are working out. And so we do this a few ways. One of the ways we do this is one of my favorite ways to look at it. But we look at those things that are living in there because they can never leave, right? We can, if we don't like how cold it is in Indiana this week, we can go normally visit another state that's a bit warmer. But fish can't move like we do to a whole different body of water. And so using these organisms, we're able to see if they're present in a location or if they're not present in a location, what that means about the health of that body of water. So when we're fishing, we do that in a non-traditional way. When you guys and girls go fishing, what do you need to fish? What do you use to fish? A fishing rod, yeah, a hook. You need a pole.
There we go. Fishing rods, hooks, poles.
Oh, Harry has never been fishing. Harry, you need to go fishing. You need bait. That's the bait. You need a worm. When we do this for science, we can't use those things. You know, if you've ever been fishing before, you can only catch one thing at one time, and it takes a long time to do that. But when we're doing it for scientific purposes, we've got to move things along a little bit quicker. So we actually do something we've grown up hearing not to do ever, and that's put electricity in the water. And let me show you my things. Move this chair out of the way. We use here. Can you see me?
Yep.
Flip my screen a little bit. Okay. So this is called an electrofishing backpack. It looks to me like a Ghostbuster backpack. You put it on, and all the fun stuff happens via this motorcycle battery here. And so we have electrons that run from this end of the pole to this end of the pole, and anything that's caught in this middle section, if we were in a body of water, those electrons are moving around, they'll get stunned temporarily. And that process is called electrotaxis. They're paralyzed for a little bit, they come back pretty quickly, but it allows us to catch everything fairly fast. And because we want to see everything that's there, we're looking at the whole population. We're able to collect everything in that one time. And I've got a video to show you. Where did you get it? So we got this from a company called Electrofishing something or another. I can't think of the name right now, but they're really expensive. A unit like this costs about $5,000. You have to have a special scientific permit to use it. And you have to have that permit signed off by real scientists in the field. You can't just go and get it on your own.
How do you keep from shocking yourself, Megan?
So I keep myself from being shocked by wearing a pair of waders, which we'll see in the video in a second. They're canvas, and so nothing goes through there. They're pretty waterproof, so it keeps us protected. There are also some safety features on the backpack that I can show you. And so if you can hear this, can you hear the whine? Mm-hmm. Okay, so when that's running, that means it's going. If I were to trip and fall, which happens sometimes, not as often as it used to happen, it'll get cut off. If there was somebody, sometimes we're not able to catch the fish with the nets that we have. If somebody wanted to catch the fish, I would just take my hand off of this lever here, and they're able to grab it. Somebody asked, how do we catch them? We use a net. So we use a big old fishing net, and it's about as long as this is. So we can hold our hands up here and the net's down there, and we won't have to have our hands in the water unless we're trying to get something that we can't get without the net. It's not that heavy. Go ahead.
How heavy is the backpack?
Yeah. It's not that heavy at all. The battery makes it considerably heavier, but the way we place it, if I had it all strapped in together, it kind of sits where it's supposed to, so it's not that heavy. We wear it all day long, and so, well, in my younger years, I didn't have back pain at the end of the day after working a 14-hour day. Nowadays, it's a little bit different. But we could wear it all day and not have any issues. So this is the backpack. I went out with some friends the other day, and we actually went electrofishing. Can I share the video?
Yes, please.
Okay. So this is kind of what it looks like. Not kind of, this is exactly what it looks like, and I will mute it. So usually we're standing much, much closer, and we all have our waders on to protect us from that water. I showed you what that field is. It's pretty wide, the shocking area, but if somebody was standing way back here and put their hand in the water, they wouldn't feel anything. So we do this for a while. We actually move across the whole body of water so that we can get everything that's within the stretch of stream that we're looking at. And that's about it. That's how it works. We get a lot of different species when we use this method, and I will show you here what some of those things were. And so I guess let me pause a second. So when we collect them, we measure them. We also sometimes we take weights. So we always take lengths just so that we can see how old the fish are that are living in a body of water, and we could do that with a whole bunch of different sciencey things. But then we put them back, we release them back, and they're normally fine.
Are you looking for a certain type of fish?
Nope, we're looking for everything. Usually, when I go out, we look for everything. You can change the settings on the backpack to target specific species. So I know of some people that do not sea lamprey. They do lamprey research, and they can change the settings on the backpack to only target lamprey. But we collect everything.
So what does it tell you when you catch a lot of fish, like a lot of different kinds of fish?
If we have a lot of different kinds of fish, depending on their sensitivity level. So I mentioned earlier how fish tell us different things because they're living there. Some are very sensitive to pollution, some are very tolerant of pollution. And so if we have a good mix of both tolerant fish and both sensitive fish, then that's a good stream. If we only have tolerance, like species that are tolerant to pollution, there's something going on there in that body of water that probably shouldn't be going on. And so we can sometimes backtrack where that's come from, but sometimes we just can't figure it out. We do this by using long-term monitoring surveys. And so the project that I'm working on right now is a 4-year project. We're in year 3, and we're just collecting fish twice a year to see how things have changed. Nothing has really changed right now. They haven't really implemented any practices to make any difference. The farmers haven't implemented any practices to make any changes in the water quality, but it is something that they'll do later. So here are some of the fish, and at the bottom, I wrote down their tolerance levels. So this is a creek chub. This is a green sunfish. We find both of those fish in pretty much every body of water that we sample in. They're both tolerant to pollution, but just because they're tolerant doesn't mean we can't find them in a cleaner body of water. But that's the opposite for sensitive fish. If a fish is sensitive to pollution, we're not gonna find it somewhere that's polluted, but we'll always find it, most always find it, depending on a lot of different factors, in a clean body of water. So this is a modeled scoping.
So Megan, we're getting a couple of questions about big fish, because big fish are always the most interesting to kids or adults or any.
Sure.
But tell me the importance of small fish. Some of these fish don't grow big, but
yeah.
What do the small fish tell you versus some of the big charismatic ones? What's the difference?
It really just depends on where we are. And so we're not gonna catch any big fish in these small streams. If we're closer to the river, we're gonna get those bigger fish. So smaller fish are usually, well, it depends. Small fish can be juvenile versions of those bigger fish. So they're using the streams as a refuge from those bigger fish. They may eat them in the main channel of the river. But there are some fish that they're just small. That's how they are.
I'm gonna get 2 questions out of the way so that we're done with them forever. What's the biggest fish you've ever studied, and how many fish do you catch a day?
Okay, so I don't go fishing daily anymore. I did that for 1 summer for 3 months straight. But we actually go out for this project that we're working on. We go out twice a year for 3 days, and that's it. We catch there was one site we caught over 1,000 fish in that one site, and they're only 100-meter stretches, so they're not very far.
How long did that take?
That took us to catch them maybe 20 minutes, to process them almost 3 hours. because
Wow.
we sort them into different buckets, so it doesn't take that long to count them after we measure our first 30. But when you have to count them all, and we also look for these things called delts. They're deformities, eroded fins, lesions, and tumors, because that will also help us figure out the health of the stream if they have any of these issues. So in the area that we're sampling in, they have a high amount of delts, and so it just takes us a while to look at everything before we put them back in the water. The biggest fish I've ever caught, I don't know. I'm trying to. It's been a long time since I've caught a big fish, but we actually use a bigger electrofishing unit. We use a boat in the big rivers and then in the lakes, and we're able to sample those bigger fish that way, because this wouldn't even hurt them at all. I do not find lampreys often. I found them once in a stream not that far from here. It was a brook lamprey.
So around here, what's the species you catch the most?
Ooh, around here, there's several. We get a lot of creek chubs. We get a lot of green sunfish. Here in West Lafayette, we get a lot of darters, a lot of rainbow darters, a lot of orange throat darters. Both of those are sensitive to pollution. Let's see. We get a lot of blunt-nosed minnows. We get a lot of, not a lot of bluegill. We get a good number of bluegill. In our site where we would have done the activity, we get a lot of Mississippi silveries, and that's the only place around here that we catch them. And I could go on and on. And that's how we get at least 20 different species in a sampling stretch. And it also depends on the year or the time of year. So in the spring, you'll get different fish than you get in the fall.
One of the things I'm curious about, so you talk about sensitive or tolerant to pollution. Can you describe what types of pollution you mean? Because I'm guessing you don't mean like candy bar wrappers and plastic bags and things.
Sure.
They're sensitive to other types of pollution, right?
Yeah, so it could be like an oil spill if there's excess oil running off from somewhere, off the roads that are just flowing into the drainage pipes. It could also be excess nutrients. And so if farmers are fertilizing their fields and nothing is catching all that excess runoff, those extra nutrients that are good for the plants to grow on land are also good for the plants to grow in the water. And so we'll have big old algae blooms, and those algae will use the oxygen that's in the water. And so then there's a lack of oxygen in the water and the fish can't breathe. And so that's one of the biggest things that we look at, those two types of pollution.
Okay.
And it could be if I've been sampling in places where we see like car parts in the bodies of water. And also like if tile drains are hooked up to people's septic systems, that could be flowing into the water and that'll kill a bunch of fish. Yeah, so.
Okay. So when you catch the source of the pollution, what kind of action is taken?
I don't know. I don't know what happens outside of, like, we collect the fish and then we give that information to the state and they take over.
They take it from there.
Yes.
Cool.
Someone asked why we don't go fishing during each season. In the winter, there's protocols. We follow these protocols that are standard across different states, and so we can compare our information. But around here, if the stream freeze is over, we're not going to be able to collect fish in that whole stretch of water that we normally sample in. We do a big stretch of water because there's different habitats in the sections of the stream, and we want to get the fish that are living in runs, which are the stretches of water that are living in bigger pools, which are those deeper pockets of water that are living in the ripples, which is where it kind of like sounds like a waterfall with the rushing water. Ripples, pools, runs, and I think that's it. So we're looking at those different places because fish occupy different habitat.
Did you see that question from Aaron So do different types of pollution cause different types of fish deformations?
Yes, they do. I just don't know what causes what. And so where we're sampling right now, there are fish that have tumors, and you can see the tumors. You can see they're like little white balls in the fish, and these fish are like this big, and so it kind of adds weight to their body. They're not able to eat properly, and so that's not going to allow them to live the lifespan that they should be living.
Do you ever catch things that aren't fish when you're electrofishing?
Sometimes crayfish, but not really. They kind of bounce back pretty fast. Sometimes we catch frogs, or we temporarily stun frogs, but once you take that shocker off, they just stop, and they're able to jump away.
Sorry, I'm answering questions as you go.
No, you're fine. Someone asked if I go ice fishing or regular fishing. I do not. The electrofisher has spoiled me. It takes a long time to do any kind of regular fishing, and I don't have the patience for it, because it's so quick and so easy. But we're not we can't use this outside of scientific purposes. We can't eat anything that we've collected with it. We can't save anything unless it's for voucher purposes. Everything has to go back in the water.
What would you do with a dead fish if you found it? Either if you accidentally shocked it too hard and killed it, or if there was just a dead fish out in the water. Is there a certain thing that you're supposed to do with those?
We have to dispose of it. If it's dead and it was already dead, it's probably moldy and not moldy. Yeah, like moldy and gross. We would just leave it in the water. And you can see how, if something has been dead longer than what we've had it, if that makes any sense. If we kill them while we're out there, which doesn't happen often, it's a bigger issue. It's a bigger issue in late summer when it's super hot. We try to change water out as fast as we can, but sometimes those buckets they just lose oxygen. Because when you have warmer water, you have less oxygen in the water.
Do you ever catch invasive species around Tippecanoe County? And if so, do you catch them more in the creeks or more in like the Wabash River?
So we do catch invasive species. In the streams, we'll get little carp, little common carp. That's usually what we get there. Sometimes we get goldfish. It's not too common, but we do get goldfish out there. But it's hard to catch Asian carp. So like the big silver carp and the big head carp in the Wabash, we can't really, we'll catch them if we can, but they don't get shocked. They just kind of happen. They just jump. They happen in our nets.
How do we stop invasive species? Can you give us, what is an invasive species, especially in the world of fish, and how do they get there? Like something like a goldfish, for example.
Okay, so invasive species are anything that is introduced to a location and has a negative impact on the fish living there. And so there are fish that are non-native, but not having any negative impact. But then you have the invasive species that are definitely having a negative impact. So like for the silver carp example, they eat all the food that the juvenile bluegill would need to eat. And so then the bluegill won't be able to grow into adulthood and then reproduce and then do all the things that finish that cycle. So they eat a lot of fish they eat a lot of food that those, or use a lot of resources that those native fish need to survive.
Do you have much work in the Wabash?
I used to. I have gone from the tippy top of the Wabash near Ohio all the way to the bottom of the Wabash in the Ohio River. We used to track carp, and so we would canoe down the river. For long stretches, it would take us all day, but we would canoe down the river looking for them. We have these tags that are about this big, and the fish are, they're like this large sometimes. So this doesn't have any negative impact on them. But those sensors will go past, like as they're swimming, when we're canoeing, we can put a tool down that will collect information from them so we know that fish is there. We also had stationary receivers that were in the Wabash, and so I would go scuba diving actually to pull them out of the water so that we can download the information from those. And so that is my Wabash experience. We used to do a lot of electrofishing. We just haven't in a long time, but I've seen the river.
Inside out.
What can you shed some light on? There's questions about getting stung by a fish that has spikes. Can you tell us about either truths or myths behind like catfish stings, things like that?
Yeah. So what happens is they actually have a toxin in their skin, on their skin, and so when they poke you, that toxin breaks your skin and gets into your body, and that's what hurts. And so they're not actually stinging you. You just now have that toxin inside of your body. You can avoid that by holding them different. Like this is how I hold how I hold the catfish. But you can do it in a way that like the top spine will hit this part of your hand, and the bottom spines you can kind of hold them so that you don't get poked. But I've had my fair share of catfish spines in my hand. For bluegill, I mean, you hold them by their sides. You don't get them when their ray has been expanded.
So if a fish has a tumor, or had a tumor, but it also has babies in its stomach, would it affect the babies?
I don't know. I do not know the answer to that question.
Is pollution genetically transferred or just in their bodies transferred?
I don't think it works that way, but I don't know. I'm not a geneticist. I am a fish collector. I'm a biologist.
So what all do you, besides taking the lengths and weights, like once you release fish, what do you do with all the data? Where does all that go?
So we actually send our data for the project we're working on right now. We send it to IDEM, or the Indiana Department of Environmental Management. We received our funding like down the line from the EPA, and so they transfer that information up there. But IDEM is able to use the information from the streams that we're in to kind of compare what's going on to the other streams going on around the state. And so they're kind of the hub of information, and everybody gives them that information.
Cool. You ever gone to a different country for science reasons?
Yes, I've been to Costa Rica. I actually went, one of my first experiences electrofishing was in Costa Rica. And we were trying to see the difference in fish population in streams that were covered by canopy, so like a whole bunch of trees, and then streams that were in open pasture areas. So that was a lot. Those fish were gorgeous. We have pretty fish too. We have a lot of fish that will rival tropical fish in color. But man, that was awesome.
Wow.
That was
Do you like your job?
I love my job. I do. I love being able to do hands-on stuff with kids. The virtual version of these has been different because I like that face-to-face contact, but I absolutely love what I get to do. I love when you all hear something that like really sparks your interest, and then you kind of pursue that information more on your own, or you decide to come to Purdue and get an education in this area. You just like, or go outside more and kind of explore. Just don't, you all like take the information you're giving right now, and then you do more with it later. I love that. I love being able to help with that process.
Yeah. That's great advice. What is your favorite type of fish?
My favorite type of fish is a Johnny Darter. Okay, so there's two. So Johnny Darter is a freshwater fish. They're about this big. There's nothing too special about them. They have little W's on their side that looks like Charlie Brown sweater. But they're cute. They're just these cute little fish. My favorite marine fish is an ocean sunfish. They're giant, like these big old fish. They look like pancakes, essentially, like vertical pancakes, but they'll turn on their side, and then birds will come and eat all the parasites off of that side of the body, and then they'll turn to the other side, and then birds will come and eat the other side, and I find that so fascinating.
That's cool. I think you answered it on your poster, but how long have you been working in this field?
7 years.
7 years. Wow.
7 years.
Wow. That's really cool.
And I've been doing stuff in here about 10 years. So I started in the lab. I worked on my first project in 2010, actually. I was looking at how sediment, so another form of pollution is also sediment. So a lot of runoff and erosion that's coming from the stream bodies, looking at how sediment impacts essentially the breathability, the oxygen intake of the fish with different sediment levels.
So have you seen any improvement on anything since you've been out, or any decline? Or is it, I know you stated earlier where everything's pretty much the same, but since you started, have you seen better, worse, or just the same all the way around as a whole?
So I've seen landscape changes for sure in the last several years. By several, I mean like 7 years. Just going back to some locations that we were sampling in my beginning days here, they look completely different now. And that's just the hydrology changing how the stream is formed. As far as populations, I haven't worked on a project long enough to see. So there's one site where we put in 2-stage ditches. And so streams normally, or agricultural streams normally cut into a V. But what they did there is they had 2-step levels. So you had your V, a level of vegetation, and then you had another drop, and then that was the stream. And so we were sampling before the 2-stage ditch was put in, as it had been there, but we didn't have any more funding to go back years down the line to see what kind of impact that had. There has been research done, but I haven't seen it personally, what's happened in our bodies of water.
Cool. Neat.
Somebody asked, let me make sure I get it. Somebody asked what we do with the fish if we keep them. So we put them in formalin, which helps to preserve their bodies. And then so formalin is cancer causing, it's a carcinogen. We take them after they've soaked all those in and preserve their body. We take them and we put them in a series of water to remove that toxin, and then we store them in ethanol. And I have some fish that I actually took out of the ethanol if you guys want to see it.
Yes, please.
So
we got about 2 minutes left.
Okay, so I'll go really fast and I'll just show you some of the things. Let me move my keyboard. So sometimes when we're out, we see fish. It depends on the time of year, of course, but different fish have different breeding periods. And so like this fish, I don't know if you can see it. Okay, so this fish has breeding tubercles, and what they do with these is they actually protect their nest. They clean out that nest. They protect it from any predators. This fish is actually a baby version of a big old river fish. This is a sturgeon. That's probably the biggest fish that I've caught. They can get about this long. They're fairly skinny, but they're prehistoric. They have been here for quite a long time. And then I have this little one that also has breeding tubercles. So this is a minnow. This is a small fish. A lot of people think minnows are just small fishes, but they're not. Minnows are the largest and most diverse family of fishes. They range for something that's that small to a fish out in Colorado that's 6 foot. So they're all minnows. And they're probably, I caught one of them, one of the 6 foot fish. I didn't catch the 6 foot one. I caught like a juvenile version of it. But they're cool. They're cool fish. They're called Colorado pike minnows, if you want to look them up.
Well, look that up if you want to figure out that 6-foot long minnow, Colorado pike minnow. All right,
Yeah.
Megan, we're going to end with the question that we've been asking all of our expert guests, and that is, what is one thing that you wish everyone in the world knew about your subject area?
That is fun. We have to protect them. If we don't make sure that the water is clean enough for the fish to live in, then we're not going to have clean enough water to drink, and do all the things that we need to do with water, like farming and gardening and keeping our grass green and all those different things that we use water for. So we have to care about the fish because we need to care about ourselves.
Awesome. Good answer. Everyone at home, give Megan a quiet round of applause. She won't be able to hear you, but she'll know that you're all clapping for her. Before we go, a reminder that we're going to have another session tomorrow morning at 11 a.m. We're going to learn about bats. And so if you haven't gotten the flyer or don't know the website yet for the Zoom link, write it down. It's on the screen right now. Risa is going to tell us all about her studies with bats and some interesting things about where she comes from. And I hope you'll tune in with us tomorrow. It's going to be a really good time. And with that, I think that's it for today. Thank you for participating, Megan.
Megan, thank you so much.
Yes,
Thank
we
you for having me.
appreciate you. Bye, everyone. Have a great afternoon.
Bye.
Bye.